Hi dear all students, this is Matt Doc. So during this session, I mainly focus about relations between roots and coefficients. This is very important part in quadratic functions and quadratic equations. So especially, let's see what is quadratic first. Ax squared plus bx plus c type we call quadratic. Mainly we have quadratic functions, quadratic factors and quadratic equations. So this is quadratic equation type. Then ax squared plus bx plus c, here power 2 expression, that means degree 2 relation, we call quadratic relation. So here quadratic equation contain roots. Actually there are two roots. Root means solutions. So in other words, solutions mean x-intercepts. Solutions mean x-intercept. Here I have given here that alpha beta are roots of a quadratic equation ax squared plus bx plus c equals 0. Then those are x-intercept. Solutions mean roots. They mean intercept, x-intercept. So the relation between roots and coefficients, here alpha beta roots, then we call a, b, c are coefficients. Coefficients. So in quadratic equations, the relation between the roots and coefficients, we used to check sign of the roots, and we use this relation to get another equation. Likewise, there are few more things we discuss under relation between roots and coefficients. Okay, let's see one by one how to derive relation between root and coefficient first, then thereafter the application between roots and coefficients. Let's go further. Okay, now ax squared plus bx plus c equals 0 roots alpha beta. Alpha beta. Then if roots alpha beta, we can rewrite this equation like factor form. X minus alpha times x minus beta equals 0. Here same solutions we can obtain alpha beta for this as well as x minus alpha times x minus beta equals 0. But when you consider x square coefficient here, x square coefficient they are a, but here x square coefficient 1, x square coefficient 1. Therefore solutions are same but equations are different, no? But if we put a here, then x square coefficient, x square times a, x square a, then coefficient same and also solution same. Solution same. Then now because of this, these two equations are identical. We call identical relations. Therefore, let's write ax squared plus bx plus c identical to a times x minus alpha, x minus beta, the relation identity. Now divide by a, x squared plus bx plus c, divide by a, divide by a. Now expand this, x squared minus alpha plus beta times x plus alpha beta. Here x square minus x beta minus x alpha plus alpha beta. Here quadratic identity. Now we call simple ABC are coefficients. Simple ABC are coefficients. Alpha comma beta we call roots. Simple A, B, C are coefficients. So for quadratic equation, definitely we know A, B, C real. Here A, B, C usually real and A not equal to 0. A not equal to 0. That means first term must be there. First term must be there. Then A not equal to 0. This is quadratic equation. Now, by equating coefficients, you get x coefficient. Here we have b divided by a, and here we have minus alpha plus beta. Minus alpha plus beta. Then by equating constant, here c divided by a, then corresponding constant here alpha beta. Then the relation between roots and coefficient is this. Then here alpha plus beta, now onwards we write minus b divided by a, and alpha beta we write c divided by a. This is we call the relation between roots and coefficients. The relation between roots and coefficients. That represent root sum, here root sum, and here that represent roots product. That's how we prove the relation between roots and coefficients. So in other words, here alpha plus beta, B mean x coefficient, A mean x bar coefficient, then C mean constant term. Then for quadratic equation, here onwards you can write directly relation between roots and coefficients. Okay. Then for any quadratic equation, we have the relation between roots and coefficients. Not only for quadratic, but also for cubic equations, and biquadratic equation also has relation between roots and coefficients. Okay. Let's see few applications with relations between roots and coefficients. Let's move further. Okay. Now you consider alpha plus beta and alpha times beta. Let alpha plus beta and alpha times beta. So without finding alpha beta, we can check the sign of the roots by using the relation between roots and coefficient without solving the equation. So here also we derive roots relation without solving the equation. But by solving the equation also we can obtain similar relation. Okay. Now let's go for that. You consider ax squared plus bx plus c equals 0. This is the way of obtaining solutions. X square plus b divided by a, use complete square method. C divided by a equals 0. Then x plus b divided by 2a whole thing square plus c over a minus b divided by 2a square we call complete square method. So when you expand this, you can get previous line and the previous line. So I told you here a not equals 0 because we need to divide by a there. Then quadratic mean x square term must be there. That's why we put a not equal to 0 or a not equal to 0. Now you subject x plus b over 2a squared. Then take the other side, b squared over 4a squared minus c over a. Then b squared minus 4ac divided by 4a squared. Then x plus b over 2a, subject it. Then we put square root b square minus 4ac divided by 4a squared with plus or minus. Then subject x minus b plus or minus b square minus 4ac root divided by here 2a common 2a. Here we call these are roots. We call alpha, beta. So those are solutions. Those are x-intercept. So by adding these two, also you can obtain the roots relation minus b divided by a. And also by multiplying these two, again you can obtain the root product. Okay. Now the roots relation we can derive two different techniques. One is identity relation and the other one is solution. Okay, let's move further. Then alpha plus beta, you take one value alpha, let alpha equal minus b plus b square minus 4ac root divided by 2a, and beta equal minus b minus b square minus 4ac root divided by 2a. So then alpha plus beta, therefore alpha plus beta, you add these two, cancel second terms, then minus b minus 2b divided by 2a minus b divided by a. That's how we obtain root sum. Then similarly, we can go to root product. Then alpha times beta, here minus b plus b square minus 4ac root divided by 2a into minus b minus b square minus 4ac root divided by 2a. Okay, now we can simplify this. Let's move further. Okay. Now, here we can see difference of two square terms, no? Difference of two square terms. Then here b minus b square minus b square minus 4ac square root square 2a 4a square. Simplify b square minus b square plus 4ac divided by 4a square. Then cancel b square. Then here cancel 4a. Then c divided by a. Then root sum and root product also we can obtain like that. Now let's go initial discussions. That means how to find sign of the roots. How to find sign of the roots. Let's move for that. Then here alpha beta. So here we can have three possibilities for alpha beta. So that can be positive, that can be negative, that can be zero. No? That can be zero. We have three possibilities for alpha plus beta, alpha times beta, and alpha plus beta and alpha times beta. Here we have three possibilities. So if alpha beta 0, that means at least one root 0. At least one root is a 0. Then when alpha beta negative, then one is positive, the other one is negative. Then we say roots are opposite in signs. Opposite in signs. Then when root product is negative, we say roots are opposite in signs. So when roots product is positive, then we say roots are same in sign. Same in signs. When root product is positive, roots are same in signs. That means both positive or both negative can be happen. So now with this one, alpha beta positive and alpha plus beta positive. Then because of this we say roots are same in signs. That means both can be positive or both can be negative. So with this one, if these two are negative, this cannot happen. No? Then surely alpha beta must be positive. Then if alpha beta greater than 0 and alpha plus beta greater than 0, then roots are positive. That means both roots are positive. Similarly, alpha beta greater than 0 and alpha plus beta less than 0 condition. Then here by this we say both roots are same in signs. Same in signs mean both can be positive or both can be negative. So when you go for this, then alpha plus beta less than 0. No? That means surely both roots are negative. Then if alpha beta greater than 0 and alpha plus beta less than 0, then roots are negative. Both roots are negative. Then that's how we consider sign of the roots. Then special thing, alpha beta less than 0, roots are opposite in signs. If alpha beta less than 0, roots are opposite in signs. If alpha beta greater than 0, roots are same in signs. If alpha beta greater than 0 and alpha plus beta greater than 0, both roots are positive. If alpha times beta greater than 0 and alpha plus beta less than 0, both roots are negative. Okay, that's how we find sign of the roots. Okay, now let's move a little further. So this is the thing about the relation between roots and coefficients for quadratic equation. And initially I told you this relation between roots and coefficients can be for cubic equations and can be for biquadratic equation. Let's see the properties. Let's move further. Okay, now it is very simple. Now let's see quadratic first. Then you consider ax squared plus bx plus c equals 0. Roots alpha beta. Then roots relation mean root sum and root product for this. Therefore, alpha plus beta equal minus b divided by a minus b divided by a, and alpha times beta we call c divided by a. C divided by a. Here roots relation. Then we have two roots. Then we consider about root sum and root product. Now let's move to cubic equation. Let's move to cubic equation. Then ax cube plus bx squared plus cx plus d equals 0. Cubic equation. Now here roots say alpha, beta, gamma. Roots alpha, beta, gamma. Now here we have three roots. Then the relations are alpha plus beta plus gamma. Root sum we call minus b of a. Then sum of the product of two roots alpha beta, beta gamma, alpha gamma. Here this addition we say minus c divided by a. Sorry, plus d divided by a. Then root 3 product alpha beta gamma we say d divided by minus d divided by a. Then all three roots sum alpha plus beta plus gamma minus b of a minus b of a, then c of a, then minus d of a. It goes like that. Then here root sum of three roots, then sum of the product of two roots, then product of three roots. That is the relation between roots and coefficient of cubic equation. Cubic equation. Okay, this is for cubic equation. Now similarly, this relation also applicable with biquadratic and also further polynomial types. Okay, let's move. You consider ax to the power 4 plus bx squared plus cx plus d equals 0, let root alpha, beta and gamma, gamma and delta. We have four solutions for biquadratic equations. No? Then here also we have root relations. So actually for quadratic we have two relations. For cubic we have three relations. For biquadratic there will be four relations. Four relations. So alpha plus, beta plus, gamma plus, delta. Here we have roots alpha, beta, gamma, delta. That is minus b of a. Then always remember root sum minus b divided by a. Minus b divided by a. Then take sum of product of two roots. Alpha beta, alpha gamma, alpha delta, beta gamma, beta delta and gamma delta. Addition 1, 2, 3, 4, 5, 6. So that is c divided by a. C divided by a. Okay. Then further take 3 alpha beta gamma, alpha beta gamma, alpha beta gamma, alpha beta delta. alpha beta delta, beta gamma delta, beta gamma delta, then alpha gamma delta, alpha gamma delta. We have four relations for this: alpha beta delta, alpha beta gamma, then alpha beta delta, then beta gamma alpha, then alpha gamma delta, alpha gamma delta. So this is C divided by A. Here minus B divided by A, ax to the power 4, here relation wrong, ax to the power 4 bx cube, cx power, here dx plus e equals 0, wrong equation. Then here we write minus b over a, first one, then c over a, second one, then third one minus d over a, minus d over a, and fourth one e divided by a. Then alpha, beta, gamma, delta minus e divided plus e divided by a, plus e divided by a. This is the relation between roots and coefficient of biquadratic equation. Minus b over a, c over a, minus d over a, plus c over a. That is the relation between roots and coefficient for biquadratic equations. Biquadratic equations. So now you identify for quadratic equations, this relation between roots and coefficients are very important relations for your A-level examination. So this is the thing about the relation between roots and coefficients. Thank you for watching us.